Okay. Good morning, good afternoon, good evening. Thank you for joining us. My name is Ezra Pasak. I'm a software developer slash biocreator slash PDBx mmCIF dictionary manager here at the RCSB PDB. And today I'm going to talk to you about, briefly give you an overview of what's happening in the next year as we transition to extended PDB IDs, a new beta archive, and why you should be using PDBx mmCIF. So the protein data bank. Many billions have been served since 1971. It's the original open access digital data resource with currently more than 250,000 structures. It's managed by the Worldwide PDB Partnership, which consists of members here in the US at RCS PDB, in England at Protein Data Bank Europe, uh, at Japan PDBJ, uh, joined by the BMRB uh, Magnetic Resonance Bank, which handles NMR data, and the Electron Microscopy Data Bank, EMDB. We also have an associate member currently being set up in China at PDBc. So the take-home message, if you learn nothing else, is that on July 21st, 2027, we are going to be shifting from the four-letter favorite uh, PDB IDs into an extended PDB ID format, which is 12 characters long. The reason we're doing this is that we're running out of four-character PDB IDs. This will have certain implications for what you can do with our data, the data formats, and I'll get into that. Uh, the primary data should really is going to continue to be PDBx mmCIF format, which has been in use since 2014. Uh, but the PDB format, legacy PDB format, will be going away for these extended PDB ID entries. And I'll get into that a little bit more later. So the extended PDB IDs are all going to start with a format which starts PDB underscore 4 digits, and then similar to what we have now, 4HHB. This is sort of the equivalent of right now 4HHB. In the future, we'll start with PDB underscore 1 and continue on over there. This allows us to eventually do real data mining of PDB entries in the literature. So what's going to happen is any structure deposited before July 21st, 2027 will be given a four-letter PDB ID and a 12-character one, and you could use them both. We're showing you how to map 4HHB into this extended one. But after that date, they will be only the extended 12-character PDB IDs. Structures deposited after that point can no longer be represented in legacy PDB file format because the PDB file format metadata has fixed positions and fixed column widths for all the data items, and 12 characters is going to cannot be used in that fashion. All wwPDB partner sites will be searchable by both the 4-character and 12-character IDs. Not all of them are all set up yet, but we're getting there. Now, this is more intended for journals. The DOIs for a persistent identifier that we use for all our entries format will change. Our current format uses this template 10 point whatever with PDB and then the four-letter code PDB. And it'll be the same one whether it's 8Y9M or if it's PDB underscore 0000 8Y9M. So if it has the PDB underscore 0000, then the then DOIs will all look the same format. After any entries deposited after next July, we'll be using the extended PDB ID for the access to the structures. So journals should be aware of this and figure out how to transition at the right time based on what's coming in from the users. Because sometimes people deposit PDB entry or any entry to the data bank several years before it gets published, or maybe 2 weeks before it gets published. You don't know. So we put together some help guides on extended PBIDs. So all these resources, most of them are going to be available from the wwPDB.org website. This is under the documentation one. We have information on extended PDB IDs with 12 characters. We have frequently asked questions. We're going to talk about beta archive in a moment and various other help resources. including links to a guide for people interested in learning more about PDBx mmCIF format, the data dictionary, how things are mapped between the legacy PDB for the metadata, and various other resources. So to get people ready, we realized that having people transition overnight is going to be a disaster. So if you regularly download data in some automatic fashion, we put together what's called a beta archive. This beta archive will eventually become our primary archive next July. Uh, you can start accessing it now. So if you have an automatic process that downloads new structures, you can start downloading the new structures from the beta archive now and make sure all your software works. The URL I'll show you in a moment will continue to work even after it becomes a primary archive. So you won't have to update your software multiple times in 1 year. You update, get everything working, and then eventually have to switch. So we're going to reorganize the data. So the current archive, and I'll show you on the next slide, uh, we split up the experimental data from the coordinate file, from validation reports, and they're in different places in the tree. But the beta archive, available at filesbeta.wwPDB.org, we've shuffled things together so they're all back together again. So I will show you that on this slide. So the current archive, this is representing how things are organized. Reference data are things like the chemical definitions. We've moved that up a level to under wwPDB because it's used by all archives. And instead, as you work your way down, we had data structures divided, and then we split up NMR data, PDB, mmCIF, structure factors, XML. Then under each one of those, you have a two-letter hash and then the actual files. We're changing it such that now it's under entries, and you have it broken down by two-letter hash, which are the second and third from the end, and then the extended PDB ID, and then within that, you'll have subdirectories with data. So looking at the beta archive right this second, this is current entry 3LTQ, which is stored under the extended PDB ID. And within this, you'll see that there are structures, experimental data, validation reports, and assemblies. So we encourage people to start using the beta site for automatic tasks as soon as possible. It is kept up to date at the same time and the weekly update release every Wednesday. So it will continue to remain up to date. Now, trying to figure out where the file system layout is sort of magical. So we have a system set up that you don't have to worry about that. You want to get your experimental data, I mean, you want your coordinate file, just ask for it by name. You don't have to worry about any hash directories. You need to worry about where it is. If you want to have a ligand definition, you could do the same thing. You want the experimental NMR data, you could do that. And there's information again on on the wwPDB site, uh, talking about the downloads beta FTP site. And so your syntax will work today. It will continue to work 2 years from now. It will work next year. Eventually, you'll want to change from files beta to files.wwPDB.org. But if say you want to download the whole archive, we've provided some scripts to do that right now, written in Python. If you want to download a specific content type, or there's rsync access, which is a little more tricky because you can't just download one subset of the tree. Again, the same site has the details. So if you want more information about the beta archive, uh, this is available. If you go to www.pdb.org and then go to archive downloads, then there'll be a page just dedicated for this information about the beta archive, all these short links and all the data of how to download. I will also add something which people may or may not be aware of, and we currently have this in place on the current public archive, is that we have holdings files. So instead of trying to download every week, give me all the coordinate files, and I'll figure out which ones changed. We have that information about when they were last updated in an JSON formatted file. You download that file, then you can figure out, okay, I need to pull, here's the new data I need to pull and look at. And then you can efficiently pull down the data you want for any analysis you might be doing on a weekly basis. And now I'll just touch quickly on PDBx mmCIF format. So as I said, it's a machine readable and human readable format with no limitations on where columns are, column width. It's supported by many refinement and visualization programs currently, not all of them. We are aware of that. And is the basis of our other dictionaries like mmCIF, which is what you get when you download files from AlphaFold. Uh, as I said, the legacy PDB format cannot support expanded PDB IDs. 2 years ago, we also introduced 5-character ligand codes. They cannot be represented either as a PDB file format. So currently, of our over 250,000 structures, about 14,000 of them are only available in PDBx mmCIF format because we cannot represent them in legacy PDB format. And here, on the right, you can see a brief example, and you can see it's sort of a keyword described by a dictionary and a value, key value, key value. And these descriptions are all available on the mmCIF website. And you could look up any of this information. We also provide a number of resources. And if you need help transitioning what you're doing to using PDBx mmCIF, we are happy to help you out and try to give you guidance on a case-by-case basis based on your needs. So we hope that you'll start transitioning to using PDBx mmCIF now. Test your internal pipelines using the beta archive data now. Test any third-party software that you use and see if they're compatible. If not, talk to them and see what they can do. And tell a friend. And if you have any questions, feel free to contact us. So just want to say we are a fortunate team at RCS PDB. We have a large number of people with different expertise. We are funded by the NSF, NIH, DOE, and I'll answer any questions that we can discuss anything about what I've talked about today. So, uh,